All right, folks, thank you so much for joining today. Really excited to have our first episode of This Is CDR for the 2025 season. My name is Chris Neidl. I'm your host today, and I am one of the two co-founders of the Open Air Collective. More on that in a second, as well as the executive director of the Four Corners Carbon Coalition, which is actually relevant to today's guests, which we'll discuss. We're going to have Serge Bushman from Woodcache PBC on in a second. A very, very exciting company in the biomass removal area of carbon removal. So he's going to tell us about his company and the projects that they're working on. But before we do that, I'm just going to give a quick bit of an overview about the program today and Open Air, and then I will hand it off to my co-host and partner in crime, Tank Chen, who will introduce Serge, and we will take it from there. What I'll say is we'll have the conversation. There'll be a presentation from Serge. I'm going to ask a few questions to kick off the Q&A. But as we go, please do add your comments and questions right there in the comments bar. And as we get deeper into the conversation, we'll go ahead and pull those up and add it to the discussion. So again, just a little bit about Open Air. For those who are new to the program or new to Open Air is an all-volunteer-led action network focused on advancing carbon dioxide removal. We have volunteer members from all over the world. I'm in Austin, Tank's in Taiwan, and we've got hundreds of folks somewhere in between who participate in our network. And what we are set up to do is to focus on a few impact areas, or what we call domains. One of the things that Open Air is very well known for is our advocacy for pro-CDR policies, particularly at the state and municipal level in the United States, but also with some activities in Europe and other parts of the world. We have a very robust and active and fun maker or R&D community within our network. And these folks focus on basically shared citizen science projects and maker projects related to carbon removal. At some point in this first quarter of the new year, we'll have one of those projects featured on the CDR called Epiphyte, which is a open source miniature direct air capture device that's been designed by our members and is currently being built in its latest iteration here at UT Austin, where I'm based. We do a variety of educational programs. This is CDR being sort of our flagship one, just focused on raising awareness and understanding and support for CDR through various different channels. One exciting project that we often talk about here is called CDR AI, and that's a large language model, kind of like ChatGPT, that Tank, myself, and a few other members built that allows people to get good answers and content related to carbon dioxide removal from trusted sources. Maybe Tank can throw the link in for that. And then lastly, we also, our volunteers try to directly support new forms of carbon dioxide removal enterprise, whether those are business model ideas or if they are actually supporting CDR companies in some way. In a couple of weeks, we have a really cool project that we've been working on in Uganda related to that. Tank will drop in a little link to Open Air's website. There, if you want to become part of Open Air, you can join our Discord server. It's kind of like Slack, but that's the digital platform where our folks get together, talk, and plan. So hopefully you can check us out. So with that, we'll move on to our guest today, who we're really excited, and that's Serge Bushman from Woodcache. And for the introduction, I will hand it off to my good old friend, Tank Chen, who will introduce Serge, and we'll go from there. Go ahead, Tank.
Thank you, Chris. Hi, everyone. It's Tank here. I'm based in Taiwan. I'm an Open Air member. I work on communications today. We're very excited to welcome Serge Bushman from Woodcache. Serge is the founder and CEO of Woodcache. He first became interested in woody biomass burial after observing the California fires 4 years ago, not 4 weeks ago, and concluded there must be a better way to deal with forest residuals than how we're doing it now. He shortly connected with experts in the domain, each of whom have already presented on This Is CDR to learn more and position himself as impact as an entrepreneur. Woodcache is the outcome of that journey, and Serge's current position are in the part funded through the Four Corners Coalition, which is an affiliate of Open Air. So welcome, Serge.
Thank you very much. I am grateful for the opportunity to present and also to express my appreciation for both Open Air and Four Corners Carbon Coalition. Four Corners Carbon Coalition organized some funding for our operation, some of which I'll just sort of show in the next few minutes. I'm also grateful to other people who have presented woody biomass burial previously on Open Air. Ning Zhang was one, Sinead Crotty is another, and Jimmy Voorhees is another. And we sort of depend on each other in the woody biomass burial space, helping each other out, figuring out how to proceed. And the operations that we've been able to um, accomplished so far are largely based on correlations with others in the industry. Does everybody see my screen? I imagine you do. And what I wanted to do was show a video and to tell you that this video got us into trouble in a pretty significant way. And I'd like to base my discussions on this.
Oh, you're cutting out a tiny bit there, Serge, when you talk. It might be because the video is also on.
Got it. And I'll let the video speak for itself and then I'll comment afterwards. All right. So that's the essence of woody biomass burial. And I got myself into some hot water about this video because people didn't know what the heck woody biomass burial was. They questioned this wood that looks like perfectly good wood for use in a lumber mill. And it also, not the least of which is this guy who is dumping the wood into the pit is doing a completely dangerous thing. He really should be driving down into the pit and he should be placing the wood carefully. The possibility would have been that his machine would have flipped over and there could have been some accidents. So it was a really dumb thing to do. But I ended up posting this on LinkedIn and just had a remarkable response. Some people saying good work. Those were usually my family and friends, and other people saying that what you are doing is crazy, damaging, doesn't do anything for the soil, doesn't is just a huge waste of funds, and probably you're funded by some secret international cabal, and all of these things that were pushed back. And I could have taken that as insulting and as uh, 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 an excuse to stop what I'm doing, but I took a deep breath and decided really what I ought to do is engage. And the reason for that is we're broadly in carbon dioxide removal, and I'm more narrowly in woody biomass burial. And what we really need for carbon dioxide removal is to build uh, a set of understanding citizens, regulators, communities, activists, landowners, foresters to understand what we're doing and to gradually support what we're doing, or at least understand why we're doing what we're doing. And so, as I've responded to these questions, I've come across various levels of response. The first thing, of course, is don't be mad, but to seek to understand what people are saying. So I'd usually respond to each of these with, well, what is dumb about it? Why do you think this is a silly idea? And what I was often able to do is get a response and understand what it is that someone has an objection to. And so I decided I'd try and describe what some of these responses were, share them with you, and to maybe in the process also influence your thinking. Um, and I described earlier Ning and Sinead and Jimmy, who did a pretty good overview of the scientific and early stages of what woody biomass burial should be about. And I thought my perspective would be a little bit more in the operations phase and the execution phase, so that this is really kind of just a follow on to the kinds of things that my friends and colleagues have talked about before. So I'm just going to lay out some of these arguments and discussion points, mostly to figure out where people are and then to figure out what the right kinds of response would be. And so the first response I had is, do you really even believe in what climate change is, or what forests are about, or et cetera? I wouldn't ask it that way, but that's the kind of thing that I would try and assess. And I would try and set foundational understanding. Starting on the left with, there's a whole lot of fuel in forests. This is wood that's fallen down. Normally in nature, this stuff that has fallen down would burn off steadily, gradually. But our society has decided we want to prevent fire in a fairly universal way, at least in the United States, and that there is a whole lot of waste wood. That's what I call it. Other people would call it forest revenue, forest residue that is in the forests today. That's the first thing. The second thing is, climate change is a problem, right? Do you agree with that? And if the answer is no, then probably what I'd say is, well, I'm not really going to be able to convince you that climate change is a problem. Then the third thing would be, if we reduce greenhouse gas concentration in the air, we may be able to help slow climate change. People might agree or they might not agree. And this is probably the most controversial aspect of it, but we believe, and our process is based on the idea that, if you manage forests for optimal natural benefit, that's a good thing. Others would sort of argue, really what we need to do is just leave the forests alone. So these are the foundational questions. The next question is, do you know what forest residue is? Do you know how much is being produced? Do you know what it's being used for? And, in the green box here, there's a whole lot of things that just happen naturally in a forest that are produced. And by the way, in the orange, these things are largely considered unmerchantable. There are various reasons why they aren't going to a sawmill and they aren't being used in some other commercial way. And so the remainder is this forest residue, which can be a really high percent of wood in a forest. And there are a variety of processes. Whoops, I'm going to get us on the right page here. There are a variety of processes that are undertaken these days that we draw our feedstock from. And most of these are pretty understandable. This one, POL, is poles other than logs. And in this screen, these look like they are highly commercial. But what I want to assure the people when they ask me that this is poles other than logs and are considered not commercial. So even though they look commercial grade, they are in fact unmerchantable, and that's the reason why we got access to them. Okay, then the third response is, let's make sure everyone understands what we're currently doing in a forest. The ones in the orange are the things that we currently do in forests. There's natural decay, there's wildfire. Those are things that seem to happen without the involvement of man, except that because our policy for 100 years has been to prevent decay, prevent forest fire, the natural decay is actually much higher now than it is at other times, and that's because there's a whole lot more dead wood on the ground right now. Again, this is mostly in the United States. But the process of preventing wildfires, even the small ones, has created a whole lot of natural decay. And then these bottom ones are ones that humans do in order to reduce the risk of mega wildfires, which are what we're observing in Southern California right now, and have observed throughout Canada in previous years just really devastating activities. So we fight those with controlled area burns and with slash pile burns. All of these things emit carbon dioxide, or create carbon dioxide. The one that was surprising to me when I first got into space is natural decomposition also creates carbon dioxide. And that's a natural process, but the fact is it's adding concentrations of CO2 to the air. On the right, there are things that a bunch of humans in various situations and in various ways uh, do to use some of the forest residue. The stuff in green, I would point out, relative to all of the things that happen on the left, are minuscule right now. And so, creating wood products with this waste wood is pretty small, first of all, because, what you really want to do is create wood products with the merchantable wood. But any number of things with any number of benefits that are something besides sequestering carbon. And I'll point out later that all of these other things that you can do create a benefit, but largely at the expense of carbon dioxide removal in some form. They will sequester some carbon dioxide, but not nearly as much as they could. So there's a societal trade-off when we produce these other things. All right, we'll come back to that in a little bit. So this is the trade-offs point. In woody biomass burial, we create all sorts of ecological benefits, societal benefits as well, but I haven't pointed them out here. But all sorts of ecological benefits and environmental benefits, but there are some that we don't address. And so a lot of times in these LinkedIn responses, someone would say, yeah, but you're not improving the soil. Or someone will say, yeah, but you're not creating a useful value in society. Or they will say, yeah, but what you really ought to do is set up a BEX plant, and you should generate energy. And, the answer to that is, you're right. Maybe we should in certain situations, but let's sort of be clear-eyed about what we're giving up and what we're getting if you were to sort of pursue some of these other things. And then I wanted to point out to all these people that in a particular situation, the highest and best use of the forest residue varies. And I'm just laying out here in woody biomass burial the situations where it's probably the best thing. And starting at the top, there's certain kinds of feedstock that is good for us. Softwoods primarily, there's this chemical called lignin. You want a lot of lignin. And there's a lot of woods that don't work. Yesterday, I was talking with a farmer in Kansas, and he said, well, we really want to do your process, but most of our feedstock is oak. And I'm going to go and I'm going to check how much lignin is oak, but I think it's pretty low. And probably what will happen is we'll decide that's not a good place to do woody biomass burial. The next two lines are things that possibly could drive whether woody biomass burial is a good thing. The first is their energy security risk. In the United States, that's relatively low in terms of societal energy security. Whereas in Europe, the answer is it's actually probably pretty high. So the question of, do you want to generate electricity from forest residue, or do you want to do woody biomass burial? The equation is different. Same thing for deforestation. There's some places in the world where deforestation risk is really high, maybe say Brazil. And so if you were to introduce this business model, is it possible that it encourages deforestation in order to create forest residue to be used in this process? We think the answer is no, but I could see why people would think that it is a path that someone might want to take or to avoid WBB, woody biomass burial. And we've sort of carefully developed an MRV system that we think can be applied anywhere around the world to limit the risk of deforestation. But again, there are those kinds of concerns. Another one here, soil amendment. This is going to kind of come up in an example that I have in a few moments. Is people have told us we ought to be creating biochar, amending soil. The question in this particular situation where it's pasture land, people are grazing their cattle on it. You could make it better, but people aren't farming, and maybe a soil amendment is not a demand. And so the question is, are landowners willing to pay for biochar? And so that's a situation where it makes maybe more sense to do woody biomass burial. These last ones are, what are the right weather conditions? What are the right soil conditions? We would argue that there are ways you can engineer solutions in a lot of situations, and that there are scientific pathways that would enable you to do that. But so a 6 response. Wouldn't it be better to do this than that? And, we have scarce resources, and so you ought to do this rather than that. And our macro answer to that question is the moment we no longer have, in my opinion, man-made mega wildfires is the moment we have to make that decision. Because if we have mega wildfires, that means there's too much fuel on the ground, or that our forests have not been naturally allowed to manage themselves. And so my argument is the moment that we don't have mega wildfires, we really need to begin to decide whether to do this versus that. That moment isn't here. That's at the macro level. At the micro level, we really do have to make this versus that kinds of decisions. And so I wanted to point out a couple of situations between woody biomass burial and biochar where it might make sense to do woody biomass burial versus biochar. And my argument there is that if your primary goal is carbon dioxide removal, and if a lot of these conditions described here exist, that you ought to do woody biomass burial. And I just laid out a little TEA, techno-economic analysis, that sort of shows if you start with a common amount of woody biomass, in the process of making biochar, you have to destroy a significant amount of the material, even though in the fourth line, the concentration of CO2 is higher, of carbon is higher in biochar. You end up with woody biomass, carbon in the woody biomass of 500 kilos versus 212 over in biochar. That's about 2.5 times the amount. There is a re-emission rate for both of them. I have heard that a re-emission rate for biochar is 15%. The IPCC says the maximum re-emission for woody biomass burial is 8%. And what you end up with, there are different amounts of durable carbon sequestration. And the second to last line, there's a lot more CO2 that is sequestered on the WBB example versus the biochar example. But it may be even more important that in the process of creating these products, woody biomass burial emits way less compared to biochar. Now, the question here is, does that mean you should never do biochar? No. And it's because there are different kinds of materials where biochar is way better than woody biomass burial. There's also a demand for the product, the biochar, that can be used in various ways. And so the point here is this is one part of an equation that helps you decide on a micro level what it is that ought to be done. Okay, let me show this one last slide, which moves into an operations efficient CDR. And a big piece of feedback on this LinkedIn post was, look, it costs a lot of CO2 to dig this hole with, ice machinery. And that is exactly true. We think it's about 5% of the payload to use this ice equipment, both for forestry, for transportation, and for excavation. The point there is because the payload here is so high, um, the um, the exact same process in other other methodologies like biochar, by definition, must be 2.5% if it's 2.5 times the yield of woody biomass burial. So these are higher, um, not because they're more expensive, but because the payload is lower. And so there you think about the denominator there. And so it has to be higher for those two things. And then the other aspect is there are any number of processes that woodcache and woody biomass burial have to do. Like, for example, we think the excavation is like 3%, but there's not really excavation required in these other methods. On the other hand, you've got to build a factory usually. You've got to transport the material from a place, and you have to inject or spread. Like, so for example, with bio oil, you have to inject that, will emit a certain amount of CO2. So what I don't want to point out here is that, number one, these numbers are exactly right, but they are directional, and you can sort of plug in some of these other things. What I do want to point out is that there are some situations, like if your primary goal is carbon dioxide removal, um, you ought to look at woody biomass burial. I'm thinking if there's anything else in this screen. So anyway, I think that's about it. I am very grateful for the chance to present. I'm hoping there will be plenty of questions and comments, and I'll turn the time back over to Chris. I think you're going to ask some questions.
Yes, I will, and I'll bring Tank on board too if he has any questions as we go. That was great, Serge. Thanks so much. I think it was really useful that you gave us sort of a decision tree or a decision matrix for when these various different forms of biomass-based CDR should be deployed. Two things I'll say to that. Serge did name check both Ning and the folks at Kodama and the Yale Carbon Containment Lab. They were previous This Is CDR guests. I think some of the science discussion that they bring to it is really useful. So very good counterparts to what Serge discussed today. And the other thing I think that's worth noting is that we have an enormous amount of waste biomass from various different sources. So there is certainly, when considering the factors that you mentioned, there's a lot of biomass to go around, rather than a scarcity of it. So, well, Serge, let's do this. I wanted to, you started off by saying the sort of the spark, no pun intended, for you for this area of carbon removal was when you were witness to some forest fires 4 years ago. We planned this webinar prior to the LA fires. It's just a coincidence. But a lot of people might have that reaction and they don't go and start a carbon dioxide removal business. So I wonder if you could just tell us a little bit more about your past background as an entrepreneur and involvement in technology, how that actually led to the formation of the company. And you've got some great team members who are with us today, actually in the backstage. So tell us a little bit about the company as well, and currently, how it's sort of, sort of set up.
Yeah, thank you very much. So I kind of went to business school and business, large and small business path in my career. You may not have noticed, but I'm kind of old. And so I've had a career in playing lots of different roles in various kinds of business, started companies, had dabbled with the idea of, okay, I'm in this situation. What could I do in kind of the green revolution? I lived much of my life in Kansas, and they were putting up all these wind turbines all over the place. And I thought, should I get into this? How would I get into it? Do I want to climb up into one of these turbines? What would I have to add? So I didn't go at that point. But so I had been thinking about various kinds of green activities, climate tech types of activities. And after taking a detour into a deep study of data science and also working in data science for a few years, there was a moment where I kept seeing these wildfires, and it just seemed, I think that people didn't get at the time that wildfires are bad for the air. You know, it's unequivocally bad for the air. The one that we have dealt with pretty um, um, actively in the last generation or two is the particulate matter, which creates asthma, especially in the local environment. But people weren't really thinking about the fact that this is immediately putting out CO2. And I think maybe there's a little bit more of that now, but I still feel like there's not that much thought about putting out CO2 into the air. And I wonder a lot about that. I'm in Utah. We worry a whole lot about some smog, they call it inversion, that builds up against the mountains. And we think a whole lot about the Great Salt Lake, which has less and less water in it. And that is both poisonous and then also, kind of a shame to lose that resource. But those are visible. CO2 is invisible to most people, and it's a global problem as opposed to a local problem. So anyway, looking at these fires, I wanted to just keep reminding myself that these flames were, bad for the environment. The other question is, I don't remember the exact number, but there's something about the wildfires that are combined in the air are equal to CO2 emissions of maybe the sixth largest country in the world. Just huge. And so it seemed to me that instead of just being the sideline to something like improved soil or creating energy, there really could be a way to have it be central. And if you were to think about it centrally, you could begin to think about different types of objectives and think about it a little bit in a little bit more of a pure mind. And so that's how I decided that this was important. We started formally 2 years ago. We started informally about 4 years ago. And now we have two key paths. One is we go out and we operate woody biomass burial facilities. The pictures that you saw earlier is in Colorado. We're working in various U.S. states and trying to grow at the rate that the voluntary carbon markets grow or demand grows, and figuring out how to have an available product when the market is ready so that we can get enough money to continue operating and to continue to grow. Big stuff, big, set of a big constraint there. The other business we have is to consult with others who want to do a woody biomass burial product, have a lot of resources. They might have land, they might have access to or control of a forest, they might have a strong base in a particular part of the world. And we consult with them, and we also provide woody biomass burial specialized resources like an MRV system that is proven to be effective in the outside world. And then also in our space, what we have to do is set aside a little bit of money for long-term management of this credit in order to assure durability of our credits. And so we have a solution to manage that as well. Okay.
Yeah, I'd like to, we'll get into some of the technical aspects. You just mentioned MRV, and there's some other things to discuss. I mean, I think just some more questions about the business model that you have. I think one of the huge benefits of biomass burial is that it's relatively simple to pull off in a pretty distributed way. So
Yes.
that model that you're talking about working with local partners where they implement, to me is really key and seems actually quite obvious with this kind of application. So I was excited to hear that. One thing I was wondering if you could just mention is, you are a public benefits corporation, Woodcache PBC.
Yeah.
Just tell our viewers here a little bit about what that is and why you went down that road. What are the implications actually for the business in sort of real terms?
Yeah. They're goods and bads. Woodcache PBC, we incorporated in Kansas. It is a corporation, but it is a form of corporation. And legally speaking, I think you know this, but it may be less familiar to others, is that with a PBC, in theory, a management team has authority to act in ways that are not necessarily completely aligned in the near term with the interests of a shareholder. So a shareholder, at least in theory, their sole goal is to maximize return on investment and not sort of think about other stakeholders. Now, in reality, I think shareholders usually do because they recognize in the near term you might maximize shareholder value, but you're not maximizing the value of the corporation because there will be a backlash and there will be reasons to believe that maybe a short-term decision is suboptimal based on local interests, et cetera. So that's the theory. And so, in theory, the PBC allows us to make decisions for the good of society as opposed to the good of an owner. Now, what is often followed with a public benefit corporation is a B corporation status, in which you're being much more transparent and aggressive in showing that you're acting in the interests of a broader set of stakeholders than just the owners. And that's something we haven't done. But when you come across a B Corp, they've done a whole lot to prove that they're doing community, society, environmental, sort of benefits. And that's something we aspire to, but we haven't done it so far. The downside is that said shareholders who might invest in you might have a second thought because you are committed to doing things that might not serve the immediate interests of those investors. So it might be hard to get the investors, which I'm discovering is a little bit the case. I don't think that's really the reason we haven't succeeded in raising funds, but it could be one of the reasons.
Yeah. Well, great. Folks, please do pop your questions there. We have some great commentary from Billy Smith. Thanks for joining the show today, journalist from Scotland. We have a great question from Andrew as well, which we'll take in a second. But just a couple more here. I think to really spell out how this works in the real world, fortunately, Four Corners is a project that really kind of spun out of open air in partnership with Boulder County, Flagstaff, and other municipalities in the Four Corners region. And Woodcache was an applicant for our last round, where we're funding local projects that both mitigate forest fires, which we call liability biomass, and deliver carbon dioxide removal. And Woodcache was awarded a grant to actually get an actual project going, which you've made significant progress on. So maybe to illustrate for people what it is that you do, let's talk a little bit about that project. So I'm wondering if you could just sort of summarize where it is, who's involved, and what's happened so far.
Sure. And I'm very grateful for Four Corners Carbon Coalition and also Boulder County, which ponied up a lot of the funds to help us operate. About a year and a half ago, we executed a pilot project, 100 tons of wood, tiny, minuscule, not important. But we felt like a year and a half ago, what we really need to do was execute a project right from soup to nuts and care about every single component of it. So an integrated project, and including monetizing those credits. And so we felt like we had to learn how to get credits issued, and we felt like we had to figure out how to sell them. And so we've, with varying levels of success, done that. And so based on that success in execution, and also based on some timely grants from Four Corners and from the U.S. government, we drew the conclusion, without real market support, that we needed to move into a production scale mode. And so the production scale mode that we're building and have built as a result of those grants and then some funds that we had internally was to sort of execute this production level project. It's in La Vida, Colorado. That's in Huerfano County, south of Pueblo. And the pictures that we showed are the first cell of a project that we've prepared to deliver as much as 100,000 tons of waste wood buried. Then there's a multiple on that to carbon credits, which right now we're estimating to be about 1.1 to 1.3 times. There are a number of reasons why it's not up at the natural 1.8 times, which we can talk about if you want. But it gave us a catalyst, gave us a sense that we could do this. And so we've just sort of proceeded through the course of 2024, hopefully full speed ahead, but periodically we were saying, how can we afford this? And we continue to say that, how can we afford this? We do have a business model that is profitable. It's just a matter of figuring out how to raise funding that will allow us to operate. But so what you saw is the first 1,000 tons of wood or so. Next year, actually this year, we'll execute 3 projects that are about 7,000 tons each, adding up to about 20,000. And then what we will do over the course of 5 or 6 years is deliver 20,000 tons of wood, which translates into 1.1, 1.2, 1.3 carbon credits. We interact with Puro.Earth to certify our carbon credits. They send out an auditor. They rely on the data we've collected through our measurement reporting verification system, and then they grant the credits. And then we have 3 or 4 ways to bring these to market, which we are developing and expanding, and very interested in your listeners and figuring out what are good ways to bring these to market so we can generate revenue so that we can do more projects.
Yeah, and Serge, we would love to, as we've talked about before, just sort of following the progress of the Four Corners project. When you're ready, we should absolutely bring the purchase opportunities to our broader community, because you do it in quite a retail way where any individual could buy it. So to be continued. Anybody who's part of Open Air or on our mailing list will hear about those opportunities as they arise. I was about to ask a really important question about MRV, and Gaurav just asked it for me. So I'm going to go ahead and we'll take our first question. Tank, do you want to go ahead and read Gaurav's question, and we'll get into that?
So Serge Gaurav is asking about how do you ensure permanence and minimize risk like decomposition or methane emissions in woody mass burial, and how do you go about doing the MRV? And I had the same question about the long-term management as well.
Yeah. It's a really good question. Please
preface that real quick, Serge, for those who might be new to this. This is the thing with carbon removal that really quantifies it as a asset or a product or an impact. Is you'll hear MRV, 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 monitoring, reporting, and verification, where you have to be able to show the work, and there has to be enough baseline understanding at the academic level that this is a form of carbon removal that under these conditions will last this long and has these risks. So this is the all-important question for all forms of carbon removal. And so, Serge, your thoughts on how you do it, specifically, maybe more generally, about how MRV is done for biomass burial.
Yeah, very good. So in terms of assuring durability, we have a threefold strategy. We can dig into some of them. But the threefold components are really killer MRV that deals with a long-term future, hundreds or thousands of years, beyond the life of Woodcache PBC, possibly, and beyond the life of me personally. So I'm not going to be around in 1,000 years. So MRV. The second thing is a financial structure. And the third thing is the legal structure. And so, just stepping back in terms of the problem, you're right. The big difference in pricing, in my opinion, even though some people say natural versus engineered or quality versus, lack of quality, to me, the real question is how durable are these carbon credits? And that's the difference in pricing. Now, no one, including the deep earth injection guys, including the DAC guys, has enough data to know for sure whether a credit is durable. They just don't have any actual data. And so what we're all relying on is scientific theory and research in labs and, stuff that's been measured to date, but, it hasn't been around for thousands of years. So we're, kind of combining all those to sort of say, is it durable or not? And so my main point is no one has solved that problem. What we can do is we can string together the scientific theories and then measure carefully whether what's happening complies with the scientific theories. So in our case, the scientific theory is based on observations in landfills, which are kind of frankly designed to decompose. Ours is designed not to decompose. But a landfill, natural wood in a landfill is has been decided by scientists is going to be 8.8% emissions of the mass. And that's a worst case. That's considered by our industry as the worst case. And the theory is that at some point, we're going to bury this wood. Over the first 30, 40, 50 years, there's going to be a decomposition going to be up to 8.8%. A lot of the practitioners say it's 3%, but it'll be up to 8.8%. And then it's going to stop. And that's sort of based on observations in these landfills and so on. And so, so the fourth wheel to this is a scientific theory. That's the scientific theory. Then we got the MRV. We sort of measure on an ongoing basis gases that are generated down in the pit and concentrations. We also measure flux. That is, there's a certain amount of decomposition. It's coming out. It's going to hit the earth, and the gas is going to make its way up into the air. And we measure flux primarily for CO2 and methane. Happy to say we see no methane, and we see acceptable levels of CO2 so far. So that's this MRV that has to somehow last into perpetuity. We have to convince the market that it's in perpetuity. And one way we do that is we have this other company, company called Woodcache Completion Corps, which is designed to accept an endowment. So there's enough funds to manage into perpetuity this flux. And then the third part of it is, really good legal structures, access to the land, maybe even control of the land, control of the pit, prevention of doing other things, filing deeds where it's possible. And the legal structure is something that we've developed pretty carefully for our particular pit, so we hope that we'll be able to help others do that. The other issue there is U.S. laws versus laws in other countries, and can you figure out how to ensure that the property rights are of similar level or greater in those other countries?
Yeah,
so
the legal part really
yeah.
is part of the durability question. It's about what's
that's right.
The future of it. Just a couple of things to add, and then we'll end with Andrew's question. But just as a follow-up on this point, can you just kind of sketch out for us a little bit? Are there embedded sensors that are in the burial site? I'm just curious how that's actually done technically to make measurements over time that you described.
Yeah, we set out with the idea that we're going to measure the heck out of everything, and we're going to over measure, which is what we did. We do bury sensors. They're gas sensors, they're soil moisture sensors, they're temperature sensors, they are relative humidity sensors. Turns out, we started experimenting with this about 2.5 years ago, and we've gotten better and better at it. But it turns out that all of those are very important and valuable in understanding what the conditions are underneath. Up on the surface, there are these flux chambers that you can buy, and we bought at considerable expense, where you can see how much gas is coming out of the earth and measuring rates. And so that is highly precise, although the conditions in which we're measuring are not precise at all because the weather changes and the temperature changes and all that stuff. So those are kind of the two core components of it. We have a methodology for measuring whether there are particular hotspots around our pits. So we take these readings periodically to see whether there's greater concentrations of ambient gas in one spot versus the other, so we can go back and decide whether we have to do something. And then we have this other measure called a geoprobe, where we have a tube coming from the earth going up to the surface, and we plug it into a gas meter, and we measure mostly relative humidity and CH4 and CO2. So we try and do the same things different ways. Over time, what we want to do is figure out how to do those processes more efficiently, but also more effectively, and compare them against ambient conditions. Like we have a weather station out there, we have a video camera that we can sort of identify different disturbances.
That's great. So just one other quick question on, you mentioned Tank. Oh, thanks, Tank, for adding that. The recording of this will go up on our YouTube channel, Open Air's YouTube channel, right after this call, actually, so you can share this recording. Now, you mentioned about one of the things that's really so impressive and encouraging and inspiring about being in carbon removal, climate tech in general, particularly carbon removal, is that so many of the businesses that are rising, there's a straight line between academic research and pioneers, and often research hubs at particular universities. Enhanced rock weathering, biochar, DAX sorbents, BECCS, ocean. They all have these places on a map where people have been doing research, and the businesses, often the CEO or founder is one of the principal investigators in that research. And I guess it's a twofold question. One is, we've had, folks from Yale on, we've had Ning on from the University of Maryland. What is that sort of landscape around where the real research is being done in university that your business sort of rests on?
Yeah.
And then the second part of that question is, I'm really interested, as we see these horrific events that are happening in Southern California and similar things that happened in Colorado a couple of years ago in the Boulder area, to what degree is there research that's really trying to quantify how much and where biomass removal could really make an impact to make those events less common and less damaging? So those are kind of two questions, but they're both tied to this sort of the research part of it. So I wonder, any offers you could answers you could offer would be great.
Yeah. That last part, I just heard a podcast as I was traveling back from our site in Colorado, and there was a woman that was on, and she's developed this great, I hope someone can post this, but she was on, who leads a company that collects data and makes it available to big, and I'm looking at, so working with utility companies and working with municipalities, mostly in California right now, but she collects data and she tells them, look, this is the actual effect of what's going on. And it came up in the context of California wildfires, how these homes are uninsurable. And I hope someone remembers her name, but that is a definite physical business that is happening. And I'll pass it to you, Chris and Tank, a little bit later. Maybe you could put it up somewhere. Sure. But so there's, definitely, people who are beginning to quantify all of this. The angle of quantification for us, another thing, we've been working with Coconino County. They've developed places where, there's more biomass available than others, and we're using that as a factor into figuring out where we're going to put a facility. And then Aryn, Aryn, I wish I could remember her last name. She's actually putting out this thing that identifies where municipalities can say, look, we have too much biomass. Could you place your facility here? And it's,
you got to share that with me, Serge. I would love to find out more about that. That sounds really useful.
I'll share all of those. And then quickly, with regard to your first question, which was the interaction between academia and operations, the right thing for us to do would be to wait 5 or 10 years so that tests and trials could be completed, or at least more formalized, so that we could make decisions. Unfortunately, we don't have those 5 or 10 years, in my opinion. I believe that in woody biomass burial, we really ought to scale fast. My goal is a gigaton of carbon removed each year starting 2035. It's possible. It's definitely possible. And then, the only constraint would be, can the market keep up with us? Demand keep up with us? But I think it could really make a big difference. That said, we can't wait that long because we need to start removing carbon right now. We have great relationships with academia, especially with the Carbon Containment Lab. They actually have set up a facility on our site, and they're doing much more precise measurements than we are. Meanwhile, what I'm working on with the data that we do generate for our own internal use is to make it of sufficient quality that academicians could use it in support of some arguments that they're making. It's an additional data point that we could all consider.
John just shared, I think it's Aaron Garswood at BDO.
It's Aaron. Hello, Aaron. Yeah, we just connected again.
Crowdsourcing that answer for us. All right, let's do one last question, which is appropriate given what's happening this week. And shall we go with Andrew's question to end, Tank?
Yeah. So let me just find it here. So do you have it there?
I'm just trying to find it. We have a long list of comments, but I'll put it up in a second.
Hey, and by the way, Tank and Chris, if there are questions and you wanted to pass them to me, I'd love to respond directly unless you want to do it. But I'd be happy to do that after the fact.
Yeah. So here's a question on the regulatory side of things. How do you anticipate a change in your business model for the new government administration that's coming in until 2029?
Yeah, it's a really good question. And the until 2029 is a big open question, isn't it? Not really also a perpetual, state that we will be in. Who knows? But I'm just reading the tea leaves on one hand. On the other hand, trying to avoid what I see on television because I feel like a lot of it is noise and less, a signal. Last time we had a Trump administration in the U.S., which I think is what you're referring to. Apparently, a lot of good things happened, and part of it was responsibility transferring to businesses and individuals in an environment where they felt like the government wasn't going to be that interested. I hope that happens this time, and I do believe that there are all sorts of, in a complicated system, there are all sorts of unintended or understood things. So I'm inclined to think it's more bad than good, but maybe there's some goods and we sort of have to figure out how to gravitate and adapt to those goods so that we all can push forward and, continue to accomplish the mission that we're all engaged in.
Yeah, well, we'll have to keep our eyes on this. One thing I will say, though, is that the federal government has done something quite heroic over the last 4 years. And regardless of what happens, a lot of that can't be clawed back. I think that it's something very important. But particularly for solutions like yours, it might be relevant to larger, more industrial applications. So much can be done at the municipal, county, state level that we don't need to depend only on what Washington kind of bring to bear. So I think just like we did in 2016, we're probably going to see a real sort of shift towards a lot of action at those levels. And I think that biomass burial is a good fit for activities and initiative on those levels. So with that, Serge, I really want to thank you so much. It's fascinating. I'm so pleased to see this project really taking shape. Please do keep us posted on how things evolve, and we'll continue to communicate that to the open air community as well as any upcoming opportunities for folks to purchase credits from you. So thanks so much, Serge, and thanks so much, Tank. Just to end us off here, next week, we're back. Really excited. We have Matt Schmidt, who's the CEO and founder of Structure Climate. Matt and I have been talking for a while now. He's based in Minneapolis, and he's been looking at some very interesting ways to do financing, both debt and direct investment for carbon removal projects. He's been thinking very creatively about that. So he's going to be on next week to talk a little bit about Structure Climate, but specifically feature some of those approaches. So if you're in the finance side or look for finance, that would be worth tuning into. And then following that, one that I'm incredibly excited about, and you can look on the LinkedIn Tank or Luma for registration, is we'll have the Naka Valley Biochar Project. This is actually a mission of Open Air in collaboration with the Naka Valley community. That's Africa's oldest refugee settlement in Uganda. And for the better part of 2 years, we've been working on a business in the camp run by the refugees who live there. And we've gone through all the processes in the auditing, and they're producing biochar. And starting on the 4th, we're going to be selling some of those tons directly. So we'll be talking about that project, but we'll also be talking about the really interesting way in which you can sell CDR. That's almost as innovative as the model itself. So definitely join that if you're interested in biochar or development. That'll be an interesting session. I'm really, really excited about it. It's been 2 years in the making. And with that, we'll call it a day. But thank you, folks, for joining. And again, please do look at the video and share. So with that, we will end the stream. Thanks, everybody.